And yep, I am live. That is pretty nice. And today is 21st of October 2025, Tuesday. And with that, let's begin. And yes, we will continue moving forward and we will complete the whole thing. Not the whole thing, but yeah, we will start from where we left off the last time, which is we were implementing event loop and we had written the event loop code for the event loop side, and now we have to write the application side code for the same thing. Yep, application code. And this is cool. This is cool. Emacs skill set check. If the server was running, yep, it was running. And Emacs target is missed. My bad. Missed. Yep. And yep, right. Event loop. We have written event loop. Now, what we can do is before moving on to writing code for the application side, what we can do actually is we can rewrite this whole thing again once more so that we do know that we understand what has been happening till now. And yes, the screen is visible, and that is nice. Yep. There were a few things that we were doing. Yep, yep, yep. And yep, we created some things. Yeah, okay. What we can do here is delete the whole thing. Wait, why is it read only buffer? That is crazy. Delete that other thing and lazy update. Mhm. And synchronize. Yes, synchronization. Yep. And we can delete and then rewrite so that revision, right? The revision and repetition is pretty cool. What do we need for the event loop code? Let's see. We need some things for the event loop. The main purpose of the event loop is the pseudocode is kind of like we have a list of sockets. We have a list of sockets, and what we need is we will uh, pass this list of sockets to a function called poll or some function, and that function will return a list of sockets which are ready to listen right now. And then we can call the listen or read or write call on these sockets which are currently ready so that our application side code is not wasting time. And that is cool. Yep. After this, just read and write on ready list. Yep. That is the whole idea about this thing. And this poll function, it has its own syntax, of course. It has its own syntax, and I think it returns void. No, it doesn't. Man, poll. It does return int, and the first thing is a structure FDS, which is the structure of which describes a socket which you want to listen on. And yep, yeah, and I think that SDS structure or struct poll, it is called poll FD. Like, what is the description of a file descriptor in terms of poll? And it has an integer FD file descriptor, and it has a few other things. First was another integer, yes, and that integer contains the flags or event and then another R event. Yep, I think that is the whole thing. Yep. So this file descriptor has a few things. These are the things. Yo, that is crazy. Okay. This is the file descriptor fd, and this integer event, this is the thing which the poll function is going to use to see what are the actions we want to perform on this file descriptor, and our event would tell us after calling the poll function which events from the events which we wanted to perform the socket is ready for, and if it is ready for these events we can just do them, right? So yeah, we need two file structure, and also we need another thing. We need another file descriptor, another structure which we can write right here, struct, and we will call it a connection struct. And in this, first of all, we will have the file descriptor. Then we will have some Boolean values, or yeah, we will have three Boolean values. Want to read? Do we want to read from this file descriptor, or we want to write on this file descriptor, or we want it to close? Yeah, close the connection. Let's say they have some default values. By default, they are all false. And also, they should have a buffer, a read buffer and a write buffer. Yep. A read and a write buffer. And that would be a string, std, string write, std fix available. And you would have std, another string, read. Yep, this makes sense. This makes sense. Or what else would we need? Yes, we need to know a connection. Of course, we need the file descriptor for some connection. We want to know, do we want to read, do we want to write, or do we want to close this current connection? And then this thing, write. We cannot write in like, yeah, in just one go, one write call, and we cannot read in just one read call. So yeah, we will store a buffer of for reading and writing. And there was this, no, not this. They had described this thing. They are storing this as a vector, which does make sense instead of using a string or using a vector of unsigned character. Does make sense because what we are getting is not are not ASCII characters. What we are getting is just literally unsigned characters, unsigned 8-bit characters. So using a vector here makes actually more sense. Unsigned u int 8t. Yep, for write, and the same thing. Vector unsigned 8-bit for reading. And we don't have a vector. Now we do have a vector. That is nice. Yep, that is going to be our data structure. And what we need to do now is just create our main socket if, and yes, at this point I have written this thing a few times and repetition is pretty cool. Sock stream and 0. You have to include the header file for this, which is sys/socket.x. Yep. Now we have a file descriptor. We need to set some options on this thing. On s1 set, and yep, int n. Do we need to take in? And I don't think we can just call set sock option on this file descriptor. We want to set a option on the socket layer, and yes, and the option is going to be socket reuse address. Reuse a adder option, and the value is going to be the address of this thing and size of font. Cool. Now we have set option. Now we need to put in the address and bind the address to the socket, for which struct, yes, it's struct sock adder in adder initially empty, and we have to set options on this thing. Like, what is incomplete type? What does incomplete type mean here? That is crazy. I think I have to include some other libraries. One is net inet. Yeah, net inet in dot h. Yep, that is root. And okay, now we need to set in the family for this thing, which is IPv4, which we specify using this. This is this macro, I suppose. Yep, macro. It is a macro, and the value is 2. So we use the number 2 to define IPv4. And now we need to set in, not family, we have already set in the family. The port we can say is 1234, but we cannot directly say 1234. We have to convert the format in which our machine defines the number 1234 to the format in which the network defines 1234, over which we are talking. And we have, therefore we have to pass 1234 to this function, which says host to network. And small means this is using 2 bytes, that is 16 bits of memory. And now we have to set in the actual address, IP address, mm, for which this is somehow the structure where we have to do that. And now socket host to network long and 0. 0 kind of means local network or local host. Int n equals, now we are going to bind our socket fd to this structure. We have to give in the address of this structure, addr, and we have to give the size of this structure. But this is not enough. We have to typecast this pointer, this adder pointer, to another type, which is cost struct sock adder pointer. Now it is okay. And the bind function returns -1 in case of error and 0 in case of no error. So if n, then print error, couldn't bind. Yep. And then we want to listen on this thing. Listen and bind, start listening on this fd file descriptor. And also, let's say 20. 20 would just mean that do not increase the size of your queue more than 20. So that is okay. And again, we would check for error. Listen also returns 0 in case of success and -1 in case of error. So if error, then we would say print error, couldn't listen, like deaf or something, I suppose. But after listening, we now have to get our hands dirty with this thing, and we need 2 data structures. In our pseudocode, we had this thing. We have to create a list of sockets of to which we are connected to, and then we will call the function, the poll function, and then we will read and write on the sockets which are ready to be read and written from. So we need 2 vectors, standard vector, std vector, and yeah, shit, instead of using standard vector, what we can use here is using std vectors, right? That is good. And using, no, we are not using anything else, so this is nice. here vector of connection pointer, and we will call this FDS, file descriptors. Initially, this is empty, and then we need to import the poll library for calling the poll function include, and it is also literally called poll.h vector struct poll fd, yeah, poll fd, and we call this Redis. And now while true, since this is our event loop, this will just continue running and never stop. Now what you have to do is create a shit. This is not the ready list. This is poll list, like the list which we are going to send in to the poll function. Now what we will do is we will clear this whole thing and we will continue. We will add things from file descriptors list to this thing, right? So, but the first thing, poll list dot, yeah, the first thing is always going to be the listening file descriptor. The file descriptor, this one, the server file descriptor on which we are listening, actually listening for events. Yes, that makes sense. So here we will create a struct for poll fd, and we will call this str or anything, does not matter. The first thing is the file descriptor, which is fd. The second thing is the argument on which, like the flag which specifies which event we want to do on this, and we only want to read from this listening file descriptor, which means poll in, and then 0. Last one can be anything, doesn't matter. And then this is the first thing in our poll list, pushback stir, as in the structure, not a string. And now we will start to iterate I less than fts dot size r plus plus, and yep, we are at the current connection, and we want to add this connection to our poll descriptor, to our poll list. So yes, we first of all will have to create poll fd, and let's call this a structure, and this thing will have the first argument is going to be the the first argument is going to be the file descriptor for this current socket, this current connection, which is fds. Go to the I fds, get its file descriptor. The second thing can be 0, third thing can be 0. That is nice. This one doesn't specifically has to be 0. We can also look for errors. Error, yeah, look for error. And if we want to read on this socket, then if fdsi if we want to read on this socket, then we will do str dot events take or of this thing with poll in, and I think using curly braces would make more sense. And if you want to write on the socket, I want write, then we can say we can like turn on that flag and the events take or of this thing with poll out makes sense. And now we can just push this onto our list, our poll list. Poll list dot push back this thing str. Cool. Now we have our list, and that is pretty cool. 1 minute. We have our list. Yep, we have our list ready. This thing, list of sockets. And now we need to put this list, call our function. We can call the poll function right now. And that is pretty cool. Right. Let's see. I do not remember the exact syntax for the poll function. So we can just look it up in the manual page here. The first thing is going to be the list which we just created. The second thing is going to be the size of the list. And the third argument is going to be the timeout. Look for any ready sockets in this list for this much time. And if the time runs out, then return or like give some error. And in this timeout argument, we can say -1, which would mean just keep looking till you get any socket which is ready. And also, what are the return values? This returns the number of descriptors that are ready, or -1 if an error occurred. Okay, that makes sense. Or returns 0 in case of time limit expires, we will give -1. So we don't have to look for that. But in any case, int n equals poll, call the poll function on FDS, not FDS, but poll list. We don't have to give in the poll list like that. We have to give in the address. Poll list and how many would be the size or poll list dot size, and time limit is -1. Hmm. Poll list L is small. No matching function false. So something is wrong. Poll list. Poll list is a list. Shit, yes. We don't have to do this. We have to say get the data from this vector, because we are not passing this as a vector. We are passing this on as a array. So that makes sense as a like normal array. Hello. But how? But now I have a problem. Can you say how you configured a terminal? Wait, shit. Earlier I used my ZSH, my ZSH for like configuring the terminal. But wait, you mean terminal or the shell? My ZSH is for the shell, and for the terminal, for this background, nice blur background, we have to configure the shell. And if you want to see that, then there is documents, programming, and then config. Yep, this is the configuration, and I have just these options. One theme is to make the whole theme black, this theme, and the background opacity and the blur, and one keybind for reloading, control R, and this one. Shit, I'm very stupid. Shit. Okay. Okay. Yeah, these are the things for configuring the terminal. And if you want to configure the shell, then I don't know how to do that, because I am also learning about how to configure bash. So, yep, writing bash scripts. Now, after calling this, if n smaller than 0, that, and also if n is smaller than 0 and error number, error number equals error interrupt. Okay, n smaller than 0 would mean that there was some error, right? But if that error was interrupt error, then interrupt means some other higher priority program wanted to run in at the time when our poll function was running. So our poll function got like revoked, reboot, stopped. So if that happened, then continue. Like, keep running the event loop. But if we just got a pure error, then print that, yeah, poll return and error makes sense, and then exit with exit code 1. Yep. Now we have called the poll function. Now we need to run. Now we have a list of all the sockets which are ready to read and write from. like I have to run and compile manually every time. So what is so it's annoying. Like, what do you mean in for competitive programming? For yeah, for competitive programming, you have to compile and run every time. Shit, I really don't get which configuration you are talking about. Mm. Everyone has to compile and run manually. And now, first of all, we will see before handling the read and write on all the client sockets. First, we will see if there is any new connection, and we will add that new connection to our list of all the connections. So, if and whole list 0 dot r events and bitwise and with whole in, then we can read on this. And what does this even mean? Here in the poll list, the zeroth socket, which is the first socket, is the listening socket on which the server is listening, which we added here after clearing the list. And then we created a new structure. And here the file descriptor is the file descriptor on which we are listening here, this one. So yeah, this is the listening file descriptor, the first argument, the first structure in poll list is the listening file descriptor. And we are taking its bitwise and with poll in. This would mean if still the value is 1, that would mean we can listen on this thing. Or we don't even have to do this. If this is like this has a non-zero value, then we can listen. We can make a new connection and we will make a new connection. So we can call the accept function call. We can call the accept function call. Yeah, we can call the accept function call for which will return a pointer, yeah, and handle. Since event loop does not handle reading and writing from sockets, that is a client side thing, or not client side, but application side thing. It will be handled by the application code, and this is the function which we will call so that the application knows that there is a new connection and they can handle the connection. And this thing will just take a file descriptor and return a pointer to this connection structure, which we will add to our list of all the connection structures. This thing. Okay. And here we will get connection pointer. Let's call it connect equals handle except this takes in a file descriptor, which is our literal file descriptor. Makes sense. And yeah, that makes sense. We have a connection. Now we want to add this connection to our FDS. And also in our FDS, we have a very peculiar way of storing these file descriptors. And that is in the connection list or FDS, I is pointer, like everything is a pointer, right? In this pointer to the connection structure, but the index is the file descriptor for whose structure this thing is, right? Uh, yeah, FD. So in this connection, the file descriptor, we are going to use the file descriptor for this current connection, current client connection as the index in our FD vector for this connection. Yep, that makes sense. And if the size of our vector is smaller than the index in which we want to index this, or even smaller, or even equal, then we have to resize this thing. FDS dot resize and the new size should be the index which we want to index and +1. And then we can say FDS connection FD equals this pointer which we just got. And yeah, this thing does not make sense. And yeah, that is nice. We have accepted a new connection. That is nice. Now what we have to do is we will handle the client. Yeah, we will iterate through the connections. We will iterate through not the connections, but the list that we got after we called this poll function. And if we can read on that list, then we will read on a file descriptor. And if we can write, then we will write on the file descriptor. And we will start from I equals 1 because the first file descriptor, which is the listening file descriptor, we have already handled it here. And I think I should say instead of file descriptor, I should say use the word socket. Socket makes more sense. FDS or not FDS, the arguments, the poll list dot size, I plus plus. And what do we check? No, we don't check if. We have the file descriptor, we can say int result equals poll list I dot r events, which is the result which poll gave us for this current ith socket. And if we can read on this thing, if I misspelled result again, result if result is pollen, that means read. And this way, wait, this way of checking a flag is pretty cool actually. Here we are taking AND of this thing with poll in bitwise and if the poll in flag is on in the result, then this thing would be a non-zero value. This whole expression would be a non-zero value, and it would mean the poll in flag is on, and we can write, we can read from this thing. And we will call the handle read function, which is application side function, and the read, and this just takes in a file descriptor, not a file descriptor, but this will take in shell, the whole structure, right? Connection pointer. That makes sense. This thing takes in the whole connection pointer on for the socket. Makes sense. Yep, if we can read, then we will read, handle, read, and we have to pass in the connection, which is FDS poll list I dot FD. Yep, the file descriptor. Cool, makes sense. And if we can write poll out means write, then we will do handle write and we will pass in a connection FDS poll list I FD. And also we have to declare this function here, handle write connection pointer. Cool, makes sense. And that is nice. We have done quite a few things in our event loop. Now what we have to do, we have to see if the current socket that we are at, do we want to delete that socket? Like I am asking, where will you run your program in nvim? I have to use terminal every time and run and compile. Wait, you can make a keybind for that thing? Yep, like here, I also have a keybind. I just have to press space CMP, and after pressing space CMP, this whole command runs. And I have like broken down this command into different parts. Split, I split the bash screen into two halves. I split and open the terminal and execute this command that follows. And my code, this keybind also tracks how much time it took to compile the code which I want to run. So I have extra code for that. Here in this command, I am starting the time, like, yeah, note the time, what is the time right now, then compile the code, then take note of the end time, then calculate the duration which it took to compile the code, then print the duration, and then run the file which we just compiled. So yeah, that is it. You can look this up. It says also on my GitHub and Vim RC. You go to Lua and shit. This repository is 13% C++ because of the boilerplate there. Walrus. Yep, Walrus. Remaps. This one. Yeah. Share the link. Yep, sure. And this keybind is actually like pretty cool. And the idea that we can split this into different parts is like makes sense. And you can also use maybe read these comments because this was not easy. Figuring out how to calculate the time. This was not easy. Yeah, this was not easy. There were a lot of things. First of all, we cannot use Lua to do that because when we call this function vim.cmd, Lua is like out. Lua does not know how much time it takes to run this function. So yeah, Lua is out after that. So we must do the time calculation in the bash, the terminal, this thing, in this thing. And that is like, yeah, that is difficult. That is difficult. And also event loop, that is difficult. And also bash does not have floating point arithmetic. So if you were to do echo uh, is dollar one minus one, I think this should work. This should work. Command one minus one not found. Shit. I think it is two brackets. Zero, right? This works. But if you were to do add floating point, this still works. Wait. Okay, shit, this is working somehow. See? Okay, this is working somehow. I think how is this working? This is not supposed to be working. Maybe it depends on the precision. No, it is working. Shit. No, this thing messed up. The precision is different in both the things. Shit, it is working. Okay, that is cool. That is cool. This thing is working somehow. This is not supposed to be working because bash it does not have. Hmm. I think if we were to do x equals some value, x equals 1.1 and y equals 2.1, let's say, and then echo x minus y, this also works. Wait, which shell? ZSH. Okay, I'm using ZSH. This is not bash, this is ZSH. So ZSH does have the things. Yep, you're welcome. ZSH does seem to have this thing. But if we were to do this in terminal, terminal here, and let's say echo 1 minus 1, wait, echo dollar 1 minus 1, this works. And how about this? If we add pointer, yo, that does not work because invalid arithmetic operation, bash does not have floating point arithmetics. It was working in my main terminal because it is not using bash, it is using ZSH. but it is not working here. So what we can do here is we have to pass this thing onto BC command. So what you have to do is something like this: echo 1.1 minus 1.1, pass this onto the BC command, and whatever we get, echo that. And now we get literally nothing. That is which is crazy. Yep, now it is working. Or we can, I think we can directly call the BC command minus 2.1, fatal error, like literally fatal error. So we have to pass the arguments to the BC command using as standard input 1 3.1 minus 1 2.3, pass this onto the BC command 0.8. Yep. So I had to use BC command to compile the thing to calculate the time. Let's get back to event looping. Event loop. Yep. So we have, yeah, we have done quite a lot. We had a list of all the sockets on which we wanted to listen on and write to. And we have called the application side code for handling the reading and writing for the sockets which are ready. And now we want to close connections with the sockets which are done. And how do we see that? May I DM you if I have any that? Yep, of course. Of course, yes. Yes, gave you friend request. Okay, yes, we are friends now. Hello, new friend. Hello, friend. Shit. Hello, friend, Mr. Robot. And there, if we want to read, if we want to like close the current connection dot, yeah, if you want to close the current connection, which we can see by, we have to first of all get the file descriptor for this thing, which we can say as like, let's say s equals whole list dot fd, whole list I dot fd. And if fds for this connection, what we want is if we want to close this connection, or either we want to close this connection or we got some error for this connection, whole list I dot r events, we got some error for this, which would be, and p error, not p error, it would be, wait, error is represented by this thing, whole error. Yep, whole error. If we got some error or if we want to close this current connection, the socket due to some reason, then we will just close this thing. First of all, close the S. Close is not defined because we need to include some libraries, uni std.h. I think this is the library. Yeah, this is the library. So first of all, if you want to close the connection, we will close it. Then we have to free the memory which is being used. Delete in the fds vector the s. Yep, free this thing and then make this thing null. Fds s equals null, or null pointer does not matter. Yep. So we have successfully written code for the event loop. And this thing, like day before yesterday, when we were writing this for the first time, it took about 2 to 3 hours to write this same thing. And now we have done this in 41 minutes. So that is some improvement, I would say. That is some improvement. And now all we have to write is these three functions. How do we accept a request, and how do we handle read and handle write, which is cool. Yep, this is cool. We would also need, yeah, since this structure is common, on the event loop and the application side code, we can take this and make a new vector, make a new header file on which we will be storing this, which can be imported by both the things, the application side code and this client side code. Application code.cpp, we have not written anything here. Yep, just the function definition. And we have structs.cpp. Yep. And here we have this thing, which we did the day before yesterday. We can delete both of these files now. Application side code and also structs.cpp. And let's begin from scratch. Struct.cpp. Here we have to define that structure which we defined here on the server side. Wait, not this. Uh, list buffer list ls buff or something. There is a command which we can use to list buffers event loop. Yes, we have to copy this thing and make a new file for this structure because this is common in the client side and this is common with the event loop and the application side code. So we will create a new file with the e command struct.cpp, add this here and jump here, copy, paste. Wait, these things are not declared. Vector is not declared. Include vector using std vector tool. And we only want to define this structure if this structure has not already been defined. So if it is something like if not defined, if n def connection, then this, and then and if, but this is not the right thing how to conditionally define a struct C++ or any language, any C. Okay, if define this thing, define a macro to control the inclusion of a struct member. Okay, define this, include extra member, my struct, then define the structure. And if not, wait, where is the closing bracket for this? The closing bracket is here. Okay, that is crazy. The closing bracket is later on, and we have this. If defined include member, include extra member, then do this thing, and then end if. Okay, I think I get it. If we just define this thing, which would act as this structure. Okay, as if not defined, not connection, but if not defined CONN, let's say, then define connection. I think now we can include this thing struct.cpp into both the codes. We don't even have to write this as cpp. We can rename this to hpp because why not? This is our header file. And remove this thing. Yep, cool. Now we have the event loop right here. We can delete this. And here we can do include struct include struct.hpp. And yep, we are cool. Now we have to write the application side code e application.cpp. Yep, and let's include struct.hpp. Don't have to do this. Yep. And here we will also include application.hpp or .cpp. CPP. Yep. And these three function definitions will go on the application side code. Application side code. Cool. We have application code here. We have event loop code here. All that is left is to write the definition for these three functions on the application side code. One for handling a client, one for handling read, and one for handling the write. Okay. Handling client, what we'll do is we'll get a new structure con pointer con equals new. We'll get this thing on the heap, and this takes in connection like this, and then return con. What we have to do is say that this is a client file descriptor. Wait, this is not the client file descriptor. This is the file descriptor, the listening file descriptor, on which we have to call the read, uh, call the accept function and accept a new connection. Yep. And when accepting a new connection, we have to create a new structure of type adder, include this is slash socket.h, and I think we would also need uni std.h. Yep. And struct adder sock adder in initially empty. Shit, we don't need this. We need inet. Um, yeah, include inet or net inet slash in.h. Yep, now it is working. And we will take its length, sock length type length equals size of adder, and then we will call our accept call on the file descriptor, which we this function got, and we have to pass in the address of this address data structure, which will populate this data structure with yeah, which will populate this structure with the details about the client, and we have to then pass in the length. And yeah, this is like crazy. We cannot pass in the length. We have to pass in the address of the length, and also we have to typecast this pointer to struct sock adder pointer. Now it is good. And this accept function will return 0 in case of success and -1 in case of failure. So if failure in reading, then we will print error uh, cannot accept. And let's say we will exit with exit code 1. Our server will shit. No, I don't think we should accept. We should exit the whole thing. We cannot. Yeah, we should not do that. Wait, shit. In case of this thing, we will return null pointer. That makes so much sense. If the like we were unable to make a connection, then we will return a null pointer, and therefore on the server side, when we are doing this new thing, we will say if this thing is true, only then do all of this. If this thing returns something other than a null pointer, only then do all of this. And this makes so much sense. Yeah. Yep. And okay, now we do have a new connection. If we are here on the line 15, then we already have our connection. So con, we will change the file descriptor to be equal to n, because n is the new file descriptor for the client CFD. Yeah, we'll call it CFD, client file descriptor, CFD file descriptor for the client. And we will say we want to read from this, because this is, we just made a new connection, and our default choice would be to want to read. Want read equals true, and that is kind of it. Yeah, that is kind of it. We can just return this thing after that, because what else? We have like already populated file descriptor. We have said that we want to read, we don't want to write, just read, because we want to see what the client says, and we do not want to close. We just made a new connection. And for this, write and read, do we want to initialize these things? I don't think so. I think this is already initialized. Wait, no, this is not initialized. I think now, yeah, now it is initialized. Wait, okay, let's ask this. Uh, when is a vector in a struct initialized? When actually is it initialized? Yo, hello, good morning, good afternoon. Yep. Hello, how is everything going? Down there in Australia, Team Impala dropped his new album, which is a banger, initializing a vector in struct. So I should also say C++. Vectors of struct initialization. Uh, well, not well. This thing does have a vector seeming thing. Name is name. If I were to create a new structure of this same type of subject type and do name plus some other string, would it work? Is the thing. Okay, we have created structures, and set name is a function which takes in a bunch of strings. Yes, this thing. Yes. How can I set? Wait, for the sub 0, name equals s1 gives segmentation fault. So how do I use pushback method? I have function that initializes a string name subject name to string name. Okay, yeah, that is the question. Is string this thing string already initialized or not? Makes sense. I think this would give an error, because yes, this does give an error. They are saying, wait, this should not give an error. This, yes, this should give an error because name is not initialized here. You would have to use the initialization function, like maybe this, no, this, what would it be? I think this would work. Yeah, this would work. This would work. And also this, both of them would work. Yeah, both of them would initialize the vector, I think. Let's see. Create vector, pushback element, then modify it as so. Create the vector. Okay. Okay, create a new vector. They created the vector of subjects. Then sub this thing, pushback, initialized subject, which will create a new subject. Okay. Pushback new subject created with default constructor. Vector now has one element, and they can use English equals to name, and then push back a new element and do this and this. I guess this person had problem with this part, with the main vector which is storing the structures, not with this vector which is inside the structure. Emplace, you use emplace. Yeah, we can use emplace, I suppose. Emplace calls the constructor again from scratch. Hello, you like listening rap? Specifically, any Indian rap? No, I don't like listening rap. And C++ vector, how to initialize vector in a constructor. In a constructor in C++. Nope, nope. This thing is okay. My doubt is with this. If I use this thing, is the default constructor being called? If we don't use this and this with vector, is constructor being called? C++. That is a very vague statement, I would say. Question. Uh, this thing. Yep. Yes, this thing. Default constructor of this is called. Okay, it is called. It is called. So, okay, if the default constructor is called, then that is okay. We can just leave it like this, and this would still work. Yeah. So we have written how to handle except. Now we have to write how to handle read and how to handle write. Yeah, that is nice. And these calls have to be non-blocking. Yep. These calls have to be non-blocking. We have to make this except function a non-blocking function. Yep. And how do we do that? We have to call a function called like uh, fct. There is ffctrl or something. Um, C for setting options on a file descriptor. Event loop code. Nope. Application side code. Yep. fcntl, file descriptor control or something. And we will pass in the file descriptor on which we want to set this option. And f set flag this and this. Yes. Okay. Yes, we can look this up. fcntl, and this is the thing. Yep. File file descriptors. From this provides for control over descriptors. File control, not file descriptor control, file control. The argument file descriptors is a descriptor to be operated on by CMD and like this. And what we want is to make this non-blocking. The non-blocking thing is called non-block. Okay, makes sense. Emplace and pushback. Emplace is like calling the constructor again with the arguments which you have given to the emplace function. I know him, and but I won't be able to. I have listened his songs, but I won't be able to name him. I don't know which songs he has sung, mm, created, sung, crafted, but I have heard them, but I won't be able to name them because I don't know which are his songs. And yes, pushback is like you already have your vector constructed and you are adding new elements at the back of it. And emplace is like calling the constructor again with the arguments which you have given. And okay, so how do we set up this option to make this thing non-blocking? Wait, we can do v split and then call man cnpl cnfcnpl. Now we can look at both the screens at the same time. That is nice. Yep. And we also have to make this except. thing non-blocking. Yeah, this f non-blocking. Wait, we can make a function for this. Uh, make non-block, and this will just take in a file descriptor. Yes, what do we have to do? We have to call this function with the file descriptor, which we already have, and then the command. Okay, if there were some examples, that would be pretty cool. Wait, there are no examples. Return values. No. We can just look at this, call the function with the file descriptor as the first thing, and then set flag. Okay, okay, makes sense. Control is a very high level function. We can control a lot of things. And what we want to control about this file descriptor, which we have passed in, is we want to set a flag. Makes sense. And what do we want with this flag? We will get the current flag using the same function for this file descriptor, get flag and commands is 0, and add this non-blocking. Makes sense. Makes sense. cn fcntl, which we have to include specifically fcntl.h. Yep, fcntl.h. On this file descriptor, we want to the thing that we want is f set flag. And what is the new flag? The new flag should be fcntl on this file descriptor get flag. Get flag, what is the thing for f get flag? F get flag and 0 command take or with o non block. Cool, cool. So before calling any of these functions, we can just make non block this file descriptor. We can make this file descriptor non blocking. Makes sense. And here, instead of passing in this file descriptor like this, connection, we have to get the file descriptor from this connection fd. Yep. Now we have made the file descriptor non-blocking. Now we have to read from this thing, like however we can read, how much we can read. I thought it does the same thing. I have seen many people use in place of pushback. What else can we do with place? So it's goat in India. Also, I like Raftar. I don't listen much Western music. Which genre you like? Maybe Team Impala genre. Team Impala and CAS. They have nice music. Yeah, mostly Tame Impala and just random songs are nice. Okay, now we want to handle. Wait, let's compare their and our handle accept function. Client address, size of. Okay, this part is exactly the same thing. Then set non-blocking. Okay, they are also setting this thing as. Wait, why are they? Yes. Wait. Shit, wait. Huh? Set non-block. Okay, they are setting this file descriptor as non-block the moment that they get it. Okay, makes sense. Makes sense. This makes sense so that when they are handling read and write, they don't have to make it non-blocking again. Makes sense. Here, after getting the file descriptor, we can say make this client file descriptor as non-blocking. That makes sense. And now we have to handle read. How do we handle read? This is handle accept and yep, make a new connection. Okay, shit. This is trick. This is trick. This is very stupid what we did here. Yeah, we want this connection after we know that there is a connection. Shit, this thing would have resulted in memory leak because like here we are creating something on the heap and then if in case of error we are returning early without freeing our space. So that is the error and this is fine. That was bad because of memory leak, but now this is memory safe. But this thing would never have happened in Rust. If you were writing this whole thing in Rust, we would have gotten some error till now. Okay, handle read. Now we have to handle read. We have the connection, and we know that we want to handle read. Now we need to add things onto the buffer. Okay, I think what we can do is create a char read buffer r buff and size. Let's say 64. 64 is fine. I think 64 is fine, or maybe no, no, no. Fonts int buff size is 1024. Yep, and buff size, get a character buffer of this thing and put everything initially equal to 0 in this buffer. Makes sense. And now we would like to do the read call on this int n equals read and the file descriptor is this thing, this file descriptor. Or yes, this is nice. This is nice. We can do this. This is the file descriptor and f give in the address of the buffer where we want to read and the size of the buffer, which is size of buffer size. This thing -1. There is some error. This is not defined because we had to include this library unistd. And now if n is smaller than 0, then it means we were unable to read. Print error unable to read. Yeah, just then return if we were unable to read. But if we were able to read something, then we want to parse this and we have to decide what is the protocol that we are using for communication. And in this, are they defining a protocol parser with non-blocking read, add new data to the incoming buffer, try to parse, process the parsed message, remove the message from connection incoming. You know what? Try to parse the accumulated buffer. Okay, and try to parse this. Try to parse. If parsed, then process. And if completed, if we have the whole message, then process the message. And connection incomplete. Remove, make the read buffer empty. Okay, that makes sense, I think. Now, if we are here, then it means we have read something. We will put it onto the buffer. Connection read what we have read dot assign. We have to push back some data at the back of this thing. Append. Okay. Wait, what is the function? This is just. I think this is the pseudocode. Buff append. What is buff append? Should buff append is buff append a function? like a custom function or an actual function? So this is a custom function. Data plus length makes sense. Okay. Uh, how do we push? How to push multiple elements in a vector? Push back, not like this, print the vector. Insert. Yes, insert. Insert at this location from this to this address makes sense. So we can just say connection read dot insert from connection read dot end from this place to this place and start appending from here to box plus n. Yep. And this nth byte would not be included, and that is nice. Okay, cool. So we have added this thing, and now parse. We have to write a parse function which will parse this whole thing and also tell us if, yeah, also tell us if this is like we have enough data or not for processing the whole request. And we have to use a protocol. Protocol. Yep. What is going to be our protocol? Our protocol would be the same which we used earlier at some point in this thing, in which our whole like server or no, the message, whole message would consist of two parts. This is our whole thing, and this has two parts. Yep. Here is the actual payload. This thing here is the actual payload, and here is the size of the payload. And this thing is 4 bytes in little endian notation. 4 bytes in little endian, so that the least significant byte comes first and the more significant bytes come later in the series. We can turn this green because why not? Makes more sense. Yeah, that is the protocol. And yeah, let's create a parser for this. Parser. Shit. And yeah, for the whole parser, what the parser needs to do is first check or first get the size of this payload, right? Okay, so for getting the size, that is the first part, we have to see if the message that we have gotten has at least 4 bytes, because the first 4 bytes are going to have the size. And if the size is like what we have read is not even 4 bytes, then yeah, we don't have enough message to parse the whole thing. So we can write a function which will return integer and get length, and this will take in a char pointer. No, 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 no. Char pointer. Yes. No, 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 no. No. Int get length. Yeah, would just take in char pointer ch, because we know that the length has only like 4 bytes. So all this function has to do is convert this little endian notation into big endian, or yeah, get a integer out of this, int res equals 0, and return the answer. And for this week, what we can do is take the first 4 bytes, first byte among these 4 bytes. Right? The characters are like this: 1, 2, 3, 4. This is byte number 1, byte number 2, byte number 3, byte number 4. This is, and these numbers which I am using, they don't represent anything. They are just arbitrary numbers. and to just describe what we have, or maybe I should use ABCD, that would be much better. E, B, C, and D. Right. We have this thing. What we want is D, C, B, A. We can do swap, but yeah, we can do swap. We can do swap, but we don't know the file format which our computer is using, and we have to convert this. This is a array of characters, and this thing, final thing, is an integer. So I think we have to just use manual labor to do this conversion. So we have our integer right here. What we can do is take this thing, right, and put it here. Take this thing and add and left shift this by 8 bytes and put it here. Then take this thing and left shift this number by 16 bits, not bytes, not bytes, 16 bits, and add that to our response, and take this and left shift by 32, no, 24 bits, and add this to our answer. That would make sense. So for int I equals 0, I less than 4, which is the actual size, and 4 I plus plus. And we would only call this function when we have at least 4 bits, 4 bytes of characters that we have read. And now, yep, rest plus equals add to the response ch I, get the ith character, which is when I equals 1, it would be this thing, and left shift this by I into 8. That makes sense. And that makes sense. And then return the rest. Yep, cool. And parser, int parse. Now we have to write a parser function which will read the payload and return the payload. But we also want to return error in case we don't have enough things to read from. We can say our parser function will return a string. Include string and using std. We can say that our parser function will return a string, and this takes in something. It will return a string, and if we are like not ready to parse the whole thing, then the string would be empty. And if we are ready to parse the whole thing, then the string would contain the payload. Okay. And what do we send? We will send in this vector of characters. Yeah, we will send in vector of characters, and shit, phone is going to die, but that is completely fine. Yep. Charging, that is good. Here we have the, yeah, yep. This parse function will take in a vector to unsigned characters, vector unsigned unsigned integer, 8 bits, 8 type, and this will be a reference so that we are not creating a lot of things, and we'll call it message. Yeah, or we can call this read. That makes a bit more sense. Read. Yep. And if read dot size smaller than 4, that is we cannot even read the length of the thing, then return an empty string. Yeah, returning an empty string is completely okay. But do we want to return a reference string response? Now let's return a reference to this thing. Return this. This is on the heap, a reference to stack memory associated with local variable res. Let's return a copy then. Okay, if we cannot get the size, then yeah, error. Then get the length, get len function, and we will pass in red dot data. No matching function call. Address. Nope, nope, nope. But what does this thing return? What does read dot data returns? It returns a pointer value type, pointer to value type. Should make sense, makes sense. So we have to change this thing from a character to unsigned integer a type pointer. Yep, now it is cool. Now we have the length, and now we have to read this much, or at least we have to see if the payload is enough, if what how much we have read is enough. If len plus 4 bytes for 4 bytes for the length, and length is the size of the payload. If this thing equals read dot size, if we have the whole thing, then we will process. Yeah, then we will process this. Yeah, then we will process this. And also, I'll be like right back. I have to go to washroom. I'll be right back in a minute. Yeah, let's go. Yeah, we will just begin. And yes, we have not read how we are supposed to be implementing this application side logic, application side code. We are just writing it because we know what this application side code is supposed to do. So that should be enough information for us to figure out what to do. Now, if we have read enough, if we have read enough so that we can read the whole request, then we will parse this thing. And we don't have to parse, we can just say that res dot insert, res is empty, right? Yeah, res dot insert. Wait, why do you have to call res dot insert? Yes, res dot insert from res dot end at this from this location. What do we have to insert? We have to insert read dot or read dot start or begin +4 +4 because we are saying because this is the whole thing. First, we have 4 bytes for the size, and this is the payload. And we are saying that this is payload PL, and we are saying we have read enough, and like we have read the whole message which the client wants to send. In which case, wait, shit. We will also have to write client side code. So maybe we should move these general functions such as get length and parse into a separate file so that we can import them into the client side logic, but we can do that later when we are actually writing the client side code. Okay, so we have read the whole thing. What we have to do is in our response, we will append starting from this byte here, which is the first byte in the payload, till the end last byte in the payload, for which we just do read.begin and read.end, then return res, which we can also return here. And yes, that should be enough. If we have in read enough, then this thing, and shit, if we haven't read enough, then how do we know how much we have to read? If we have the length, then how do we know how much we have to read? When to stop reading? Shit, yes, when to stop reading. That is a nice thing. Because we have not called a read function on this. Wait, we have called a read function. Wait, shit, we have. Why have we called read right here? Because we do not know how much we have to read. But we do know that we have to read. So we are reading from this client. Okay, that would also work, I think, because if we cannot read anymore, then we will put the read flag as off and it would be okay. Okay, now we can call the parse function here and get our string. String payload equals parse. We called the parse function with the read, not read. We have to give in the buffer read. Yeah, read buffer. And now if payload dot size, if we did get something, that means we have read the whole thing. We don't need to read anymore. Yep. And parse here. Yeah, if we cannot read anymore, then this thing. Yep. Then we get the length. And okay, cool, cool. If we have read the payload, then we can say we want read equals false. We don't want to read anymore. Now we have the payload. We have to process the payload. Yes. What does it mean? Let's say, shit, we can add more complexity to this thing. Let's say what is going to be the process, what the process is going to be like. Shit, we can make this more complex and we can say, shit, let's not make this more complex. I thought maybe the client would send in some expression which needs to be evaluated on the server, and that would be processing the payload. But that would be too much work just now because we don't even know how to do all of this, how to handle these things. So we can grow step by step. So mm, currently what we will do is we will see what the thing client has said. We will print it to standard output, std out, and yeah, then we will generate a response and put that response into the write vector, and we will set in want write equals true because now we want to write. Okay, okay, handle read. Yep. we have the payload, and since we have the payload and the payload is a separate string, is separate from the read string, we can make con read dot clear. We can clear this whole read vector. That is nice. We can clear this and we can process this. Yeah, we can make a separate function for this for processing this thing. Yep. Doesn't return anything. Process payload. This will get in a string reference, let's say str, and yeah, printf client is something. And what is that thing? It is this. And shit, not just this, we have to pass in the whole connection also. Printf not included, my bad. Include std io.h. Yeah, we also have to pass in the connection structure, a pointer to the connection structure, because how else? Because we also want to fill in the right vector and everything. Data. Okay. So this thing will also have pointer to the connection to the data structure, which is storing this sockets connection. And yeah, everything will be handled there. Yeah, we don't have to handle anything here. Process, payload, and this will take in the payload which we want to process and the connection, the current connection. And all of this can be moved on here. Okay. Yeah, and now we will say that we want to write to this thing. Yeah, we want to write to this thing. Okay, and shit, we can make this even more elegant and say that when this when this payload says exit, we will close the connection after this. That would actually be dope. Shit, that would actually be dope. Now, if shit, that would actually be pretty cool. If string equals exit, then what we will say is, well, these two commands are common, right? These two are common. What we will say is want to close equals true. We do want to close this thing, and yeah, that is kind of it. Then return if exit. But if not exit, then we will say we want to write, and we will also say the client says something. And also before closing, we will also print f and say client wants to close the connection, right? Makes sense. Otherwise, if the client does not want to close the connection, we'll say that the client says this thing, whatever it is, and that we want to write. And what we want to write is hello from the server. And I'm doing this thing exit because we can use telnet to interact with the client. Google.com. And to interact with the server, we would be able to use this telnet function. And look at this. If we, okay, we are trying to connect, telnet takes in an IP address and a port and makes a connection, a live connection with this IP address on this port. And whatever we type here would be sent to the like this IP address and this port, and that is nice. Shit, 8,000 is crazy. Telnet, google.com, at port 80. AT is HTTP. And now we can send in HTTP request for getting HTTP, I think HTTP and 1 1.1, I think. Look at this. That is crazy. We sent in this thing and we said send us a HTTP header or like yeah, give us HTTP something, and we got an error bad request because our request was not complete. This thing is not complete. Let's do this again and now say HTTP slash 1.0. Now we did. I think this is not an error now. Was not found on the server. The requested URL, this thing was not found on the server. Okay, let's go to google.com manually and we'll see what are the requests that are being sent. Clear this whole thing. And this was the first request. And what did we send in? Like this is the request, but we do not want to parse this thing. Get 200 remote address this and origin. Can we see the like raw request? Response, initiator, timing, whatever. But we want to see the raw request. We cannot see the raw request, it seems. Headers, preview response. We cannot see the raw request. Yeah, we cannot see the raw request, which is kind of sad. Yeah. Anyways, let's get back to this thing. Yep. If the client says exit, then we will close the connection. Otherwise, we will say that we want to write something to the client. And the thing that we want to write is, yeah, want write dot mplace. Now we can call mplace and we can say hello from the server. That should be okay. That is not actually okay. No matching arguments to this thing. Shit, no matching arguments. A character, pointer, iterator, parameters. Shit, yes. Shit, yes, we have to handcraft this thing. Yeah, we cannot just send something like this. Okay, yeah, shit. My bad, my bad. We have to write a function which will give us back the response which you want to send it to the server. So a function which will return a vector of unsigned integers, int type. Yeah, and we will say this is response or get response function, and this will take in a string str. And now, yeah, first of all, we have to append the length. Yeah, we have to append the length. And let's create our vector, which we are going to return unsigned integer, 8 bytes, 8 bits integer, which is unsigned, and response. And the size is going to be 4 plus str dot size, and everything initially 0. We can have a function which won't return anything, but we'll call it put length, which takes in the length, int length, and a vector where we want to put that length. We are using this to create our protocol. Yeah, and to create a response which adheres to our protocol. Protocol is this thing. First part is the size, then the payload. So we are putting in the size. This thing get put length is putting in the size part, and then we can put in the payload. Wait, shit. We can just call this. Yeah, put length, put length, put length is nice. Length is nice. Put length. We have to take the first 8 bytes. Okay. For int I equals 0, I less than n, I plus plus. And yep, we have to take in the last 8 bytes and put them rest I equals the last 8 bytes. How do we get the last 8 bytes? And we can do a crazy thing to do that. We can do len left shifted by, since the whole integer is 32 bits, we can left shift this by 24, shit, which is crazy, and then right shift the whole thing again by 24. We have essentially removed the first 24 bytes, and n does not make sense. We have 4 here. And what is this thing? What we want here is our integer has 4 bytes. This is, yeah, this is the LSB, least significant byte, let's call it. And yeah, these are more significant ones. What we need is this byte. We want this byte. And how do we get this byte? And there might be some numbers 0 1 something something, we don't care about them. We only want this last byte, this whole byte. What we can do is, first we will left shift this by 24. 24 means 24 bits means 3 bytes. So our number would become something like this. Our LSP would come here, and everything is now 0 0 on the right because we left shifted the whole thing. And then we can right shift this again by 24, which is 3 bytes, and what we will get is 0 0 0 for the first 3 bytes and LSB here. And we have essentially made everything here equal to 0, and we only have our least significant byte, which is nice. But there is still a problem because this thing is an integer and this thing is like unsigned integer. So we have to convert this into an unsigned integer, and I think we can do that by making this a character. We can convert this thing into unsigned int. Yeah. See, I think this should work. This should, yeah, this should work. This should work. This is like literally not giving us any error. The LSP is not giving us any error, so that is nice. Yeah, this is nice. This is good enough. We can call this function put length, given the length, and the length is stir dot size, right? And where do we want to do this? On this. At the end, we will return the response. Now we have this thing. All we have to do is put in this string onto our response. We have already have put in the size. Now we have to put in the payload. Okay. Okay. We just have to put in the payload, which we can say rest dot insert beginning at rest dot begin plus 4 and insert str dot begin and str dot end. This might give us an error or maybe not. Yeah, that is nice. That is nice. Because here in the string, everything is a character. And here in the rest, the elements are not characters but unsigned 8 bits integers. But this is still working. That is nice. That is nice. We have the response now. Yeah, after processing payload, wait, in this has to go in the process payload function we want to write, and we need to get the response. Yeah, we need to get the response, and we can say connection, right? What we want to write is equal to get response for hello from server. Cool. This get response function will mm, make this message, which has first the size and then the payload, according to our protocol, our self-defined protocol, which is nice. And I don't think we have to do anything else in this process payload. Should, but process payload, the word itself is very ambiguous. Maybe we can write it process read. But we are not processing payload when we are trying to write. So yeah, this is not very ambiguous. Right. Get response and put it onto write, which is nice. Maybe we can use move on this, which would be better. Standard move. Yeah, nice. Yeah, cool. We have write, read, and that is nice. That is nice. We have processed our payload, and that is nice. We can call the process payload. We are calling the process payload function here. Okay, that is nice. That is nice. And where are we doing our read call? We are doing a read call here. Handle read. Is that all for the handle read function? I think that is all. Here first we are creating a buffer, then we are reading onto that buffer, and also we are taking input. Yeah, also we are checking for error. If error, then we won't read and we will just return. But if we did read something, then we are putting it onto our like whole read buffer. Then we are parsing the payload. And if we were able to parse, then we are processing the payload. And after processing the payload, that is kind of it. Yeah, that should be it. That should be it for handling read. I don't think we have to do anything else other than that while we are handling the client. And also, we have something special here, and that is on one connection. We have our server, which is, let's say, red, and we have our client, which is green. And let's say they make a connection in white color. Yes. Uh, let's say they make a connection, and in this singular connection, they can do multiple request response cycles. On this single connection, they will keep doing this request response cycle until there is some like error in the network or the client says exit, which we are checking for in our process payload. We are checking if the client says exit, then exit. We want to close the function, and yep, we will print a client wants to close, and that is nice. That is nice. That is all we want to do. So yep, that is enough for reading, handle read, and we want to handle write now. So what we will do is we will create a buff. We don't have to create a buffer, and n equals, we will make the write call on this connection. Wait, we have to say this. Yep, on this connection, make a write call, right? Write to the buffer. And what do we have to write? Write connection, write dot data write this data and how much data. Shit, shit. Okay, shit, shit, shit. Okay, this is our buffer. There is a problem. This is our buffer which we want to write. This is our write buffer which we want to write. And let's say there is some size of this buffer. Let's say we were only able to write this much, right? We were only able to write this much, and this much data is still left to be written. So how do we keep track of this index from where we want to write this buffer? Do we like destroy this thing and move all the elements to the left? That would be very like log n time complexity. Or we could keep a index of this thing and we can say start writing from here, and how much do we have to write? Let's say the index is I, then how much we want to write would be the size of this buffer, size minus I. This is how much we want to write. Wait, shit, yes. I think, yeah, we can have a pointer, but yes, we could have a pointer. I think let's do it without the pointer and we will just remove all the elements which we have written. We can change it later because like this is modular. So yeah, we can change it. And how much we want to write? We want to write connection write dot size. This is how much we want to write. Yes, this is how much we want to write. And if n n n was smaller than 0, that is we were unable to write. Yeah, if we were unable to write, then print error, uh, unable to write, print error, unable to write, and yeah, uh, yeah, just that, then return if we were unable to write. But if we were able to write some amount of things out of the total size, then what we have to do is we have to see how much we were able to write. If n equals connection write dot size, if we were able to write the whole thing, then we will say on this connection we don't want to write anything onto this connection. Yeah, we don't want to write anything, and we'll say on this connection want write equals false. We don't want to write anything, and connection want read equals true. We have written, and the client does not want to exit till yet. So we'll say we don't want to write, we want to read now, and we have to also empty the buffer. So we will say write dot clear. We'll clear the whole buffer, and that is enough. That is enough. Then we can return. But if we were unable to write the whole thing, then we have to remove these bytes from the starting. This is starting data, and this would be the data that we want to write now. Yep, that is nice. It didn't work for me, so I gave up on. No, do not give up on New Vim. New Vim is very nice. Have you watched the series by Viro, Mr. Viro? Watch this thing. Wait, okay, watch this whole series, and this is amazing. Just watch this. I have watched this like 3 times now, and I think I still need to watch this one more time to understand everything clearly. So watch this a couple of times, and yeah, it will take time, but do not give up. Do not give up. We need to delete some data. Yep. Okay, let's go. Let's go. Yep, do not give up. You can DM me if you don't get anything. That would be nice. And okay, we need to delete some things from the start. So erase, we can use the erase function. Yeah. Connection, right dot erase. Okay, we are right, right dot erase and erase. We will given the iterators how much we want to erase. We want to erase right dot begin plus comma right dot begin plus n. Should right is not anything. Okay. Let's say auto reference right equals the right thing in this connection. Yes, this will do. This will do. This will do. This will do. I think we have written the whole thing. For the client side, we have written the whole thing. For the server side, we have written the whole thing. Now what we have to do is write some client side code. This is cool. This is cool. Event loop. We have put in everything in the event loop, and this is cool. Okay, this is cool. And now we have to compile G++, compile the event loop dot cpp output server fatal error event. Yeah, there is nothing called event loop. We have event loop server. It does compile. Run the server. Okay, no. Before running the server, shit. We have to, let's say, when we start listening, we will print f and say server is listening with a new line. Okay, and compile again, run the server. Server is listening. Let- Uh, let's clear a new screen. Wait, what is dev? Wait, why am I in the slash dev folder? Right, clear. And we also need the client side code, and I think we can use one of the previous codes which we wrote. Red server client request, this one, yeah, because this one also implements the same protocol, so that is nice. D++ client. Shit, this shift just wouldn't work. Request client. Okay, compiles, and yep, let's run the server. Undefined error is crazy. Cannot accept. Cannot accept. Cannot accept. Cannot accept. Cannot accept. We cannot accept somehow. Handle, right? Handle accept. There is something wrong with this and FT. FT cannot accept. Shit, if this thing is like lower than 0, then yeah, cool. G++ event loop output server, run the server. Yep, and missed dot slash client, run the client and unable to talk to the server. Connection reset by peer. Okay, and here we got some segmentation fault. shit, memory safeties. We got some segmentation fault. Is it text? Yep, it is text-based protocol. The protocol is very simple. Just this thing. The first 4 bytes are going to like contain the size of the protocol in little endian notation, and then the size of the payload, and then there is the actual payload after it. And we got some segmentation fault. Shit. We cannot even see where we got the segmentation fault. Shit, we got some segmentation fault. Whole list 0. So, okay. Okay, we did call the handle except function, so that is nice. That is nice. Segmentation fault for I smaller than I dot size. That is nice. Do this. Right here. Segmentation fault. And also we are resizing FTS. Yes, this is nice. So this should not create any segmentation fault, I would say. And here, just in case, printf working till here. Yes, and plus standard output. Yeah, let's see if this is working. Clear. We will compile the server, event loop. We will call the server. Run the server. Okay. Go to the project. Run the client. Working till here. So we were working till there. So that is nice. Then did we call the handle read function? I think we are first accepting and then we are coming here. Are we even calling the handle read? How many times are we going into this loop? Uh, printf working till here. Yep. Now recompile the server. Dot slash server is running. Okay, the loop went in for the second time, and then we got some error. Bro, want to connect with you? Can you share your LinkedIn or something? And there's the Discord. Hello, Roman Reigns. Let's go. GDB. Yo, connection is null. Connection is null. How would you know that? Yeah, there is the Discord in the like description. Yes, we can use GDB, but GDB does not work because I'm using Mac. I have to use LLDB instead of GDB. And what is Redis? Redis is a in-memory database because normal database like SQL or something, in that the data is stored on the disk, on the hard drive. It could be SSD or HDD, any hard drive, and getting data from the hard drive is slow. So instead, we can store the data in the RAM. And because RAM is expensive, so we can only store the data which is frequently being accessed. So this is like caching data in the RAM. And when our, let's say, server wants to get some data, it will first of all send a request to Redis if they have a Redis setup. And if the data is in the Redis, which is storing the data in RAM, if the data is in the Redis, then Redis will respond with the data. But if Redis doesn't have the data, then Redis will make a request to the database, and database will, for sure, database would have the data which Redis will take, put it into the RAM and send back to the server. So yeah, Redis is faster. Okay, shit. My bad. I thought he might be a bit trolling. Yeah, Redis is pretty cool. And Redis is just one of the in-memory databases. There are also other in-memory databases. Redis has its own protocol and things. Okay, so we are working till here. That is nice. What is peer list? The first connection is always the listening server where we want to read from. And then we are filling the poll list, which is nice. We are filling the poll list, which is nice. And then we are passing this as an argument to this function, which should also be nice. And if there was no error, then we are moving forward. And yes, we are moving forward and we are seeing, is there something to read right now? I don't think there would be something to read. But shit, we got this message only once when we were printing the message here. So yeah, but we know that we are getting into this loop at least twice. Let's see how far we are going. Server, server working till here and segmentation fault is shit. So segmentation fault is in this part. Okay. Segmentation fault is in this part. And you were saying this could be null. This could be equal to null. Oh, Redis is just caching over normal DB. Yes, caching in the RAM. Normal database is equal or that is also provided by Redis. Normal database could be anything, MongoDB, SQL, anything. Redis is a layer sitting in between the normal database and this dump con pointer. Yes, we will do that. Can you please shut up? How can you say I know Redis and wasting time? That is my first time here, idiot. Okay, why are you? Yeah, that is the nice response for this. Sorry, sir. Okay. Mm, yes, let's see if I also printf size is %d new line and fds dot size. Well, size is okay. There. Ah, yeah. Okay. And after this, fds. Let's just do this much first. Slash server client working till here. Size is 5. How do we have 5 connections? How do we have 5 connections? How do we have 5 connections? Shit. We do not have 5 connections. Shit, we have to conditionally put things in. Makes so much sense. Okay. Okay, shit. Yes, we have to conditionally put in things. So if fps hide, only then do all of this thing. Because in this data structure, in this vector, the index I is the file descriptor itself. We are using the file descriptor as the index. So if, let's say, the first client has the file descriptor 5, then we will store that thing at index 5 and the total size would be 6. And yes, that is where we will store. And in between, we might have a lot of empty null things. So yeah, if there is a file descriptor at this ith location, then put it into the structure. Makes sense. And that should be the like only error. Uh, Working till a client says hello, first hello from the server. That is nice. Okay, shit, we were unable to write the response. Working till here, remove working till here. We were unable to write the response, but we did get the response. We were unable to write back the response. Okay, we were unable to write to that one. Ended up C++ stream. If I don't know, caching for a demo from CP streams. Okay, shit, bro is a old viewer. Thank you for watching my videos. Okay, so the server is able to read from the client, but it is unable to write. This client was just sitting there, not doing anything else. Yes, it was not doing anything else. And also we got a blocking shit. And also our server stopped after this thing. After this, twice our server stopped because there was nothing ready. Because I think this poll function, this is the only blocking call, and this must be the call where our server stopped because there was nothing ready in the current thing. Okay, poll in, poll out, that is nice. But why were we unable to write? Handle read, handle write. Okay, if you want to write, okay, after handle read process payload, we have to say that we want to write some things. Handle client process payload, process payload connection want to read false. Yes, we don't want to read anything. And read dot clear. Yes, yes. And then printf client says this thing. Okay, we were able to do that much. And then we said that we want to write something. And then we said that this is the thing that you want to write. Should maybe this thing is being deleted somehow. We should not use the move, maybe changing the ownership. And get response. Response is this thing 4 plus size of the string, and everything initially is 0. Put length, put the length of this string, this number, onto the first 3 characters. Yes, that should also work. Yes, that should also work. And res dot shit, shit. Yes, yes. After this, we have to say len equals or len right shifted by 8. Yeah, len right shifted by 8. Yes, shit, that was the mistake. Then put is string back at the end of the response and return and put it onto right. Cool. This should work now. Here G++ uh, event loop output server dot slash server is listening dot slash line, and server doesn't say anything somehow. Why GDB not? Because we have when we are using when we want to use a debugger, when we are compiling here, let's say some compilation function d++, yeah, this thing, we have to turn on this G flag, which creates debug information, and this debug information has its own format, and the format which GDB expects is different from the format which is created here. And you could say, since we are using G++, which is GCC compiler, then the debug information which is created should be compatible with what GDB expects, but it is not, because this GCC under the hood here uses Clang, which is crazy. So Mac is just too much Clang oriented, and we have to like bend our knees, and we cannot stand against it. What we can do is launch a virtual machine. Shit, I don't have UTM, but yeah, we can launch a virtual machine and do everything we want there on the virtual machine. Hello, we are creating our own Redis, and that is like the whole theme. But the main thing is we are writing client side and server side code on our own, which is crazy. And we have written till now like sockets from nothing, from scratch. And this is code for writing an event loop, which is crazy. We have written our own event loop, which is actually crazy. And yep, that is nice. That is nice. I think we should also make some changes on the client side code to exit, to exit. Server says something, and then the client is not sending in any requests. Hello second from server. And then here we will say exit. Then we should exit. Okay, let's see. Give the first client a request, compile client. Okay, server, run the server. Server is listening. Okay. Shit, here we don't see that the client closed the connection, and shit, okay, this is not working. Oh shit, okay, I think this is because, no, this is okay, this is okay. When we uh, when we got the second string from the client, why did the server not say anything? And the server didn't say anything. Wait, maybe the server did say something, but it got messed up. How are we doing? Handle accept? No, no, no. Handle read. Handle write. Yes, we are writing afterwards. Yes, we are writing afterwards. Handle read. Process payload. Yeah, processing the payload here. Hello from server. And the whole string is going to the client. Shit. Okay. No. Want to write equals false, and want to read equals true. Yes. Shit. No. Let's say when this thing is exit, when the client says exit, we will print this line, not here, but when we are actually exiting, which is here. Client wants to exit. or yeah, F plus std out. Stop the server, compile, event loop again from scratch. I use CC with the GZDB and it works. Wait, on Mac, use CC. What is CC? C compiler with GGD. Shit, GD. This is event loop output server and GZDB is a flag. Shit, GZDB is a flag. And if I were to run GDB with server, reading symbols from this and shit, thank you. This is working. That is working. Shit. List or what are the commands? Set a breakpoint on the main function. Wait, is this on Mac? Do you do this on Mac? If shit, if this would work, that would be very nice. GDB command, GDB, run, quit, break. You have to pass in. Wait, I can use break and then function. And this didn't work because this thing does not have the required section. If I run, don't know how to run. Don't know how to run. Okay, so this is not working. Shit, we might have the debug information which we want to remove rmrf server dot dsym. Okay, and clear run the server. Run the client. Nope. From the client side, from the server side, the connection is not being not working. And the second response is also not coming here. Yep, the second response is not coming, only the first response is coming. Handle accept, handle read, handle write. And write, we are writing, write this much. Wait, I think this is not the right way to go. But anyways, I'll be right back. I have to go to the washroom and I'll be right back in a minute. Yep, I'll be back and let's see. Yeah, so GDB is not working. But why are we not getting the second response? Maybe the erase function is not what we think it is. Vector erase C++. Yeah, C++, yes, this website. Erase elements removes from vector either a single element position or a range of elements. This effectively reduces the container size by the number of elements removed. So, okay, this is working just as we want it to work. So there is no problem with that. n equals connection if the number of bytes that we have written is equal to the number of bytes that we wanted to write, then we can just, yeah, we can say it's okay. Want to write equals false, and want read equals true. And we are not writing more than we could. Yeah, we are not writing more than we could. Yes, we are not writing more than we could. And write dot clear. Yes. And then return if we have written everything that we wanted to write. And if we didn't, let's say we had like we had to write hello. Yes, let's say we wanted to write hello and n was equal to 2. Like this thing written by the write function in n, it is equal to 2, which means we were able to write two things. And we are removing everything from there till n. Yeah, which is nice. Yeah, we are removing these things. Yeah, yeah. If yeah, this is right. There is no problem with that. Hello. I mean, it is not a part of your schedule so that you have to be on time. But yes, thank you for being here again. And yes, there is some error. The client is not getting the second response from the server, but the server is reading somehow. Maybe it has to do something with the client. Unable to talk to the server. No. Exit. Talk. Okay, talk takes in a string and a file descriptor and talks. Yes, talk talks. Talk has a write buffer. So talk writes whatever the message is, and write length is also a function, yes, which adheres to our protocol. And then we have this thing. So yeah, server is writing, the client is writing correctly. There is no problem with that. But this thing is giving us some error when we are reading. Read all from this file descriptor, read everything on to this length. Wait, maybe the max, no, max buffer is not too big. So yeah, wait, shit, let's say assert length of what we have read has to be smaller than the buffer size. Maybe this will give some error, and that would be nice. This doesn't even compile. G++, wait, shit, what did I even write there? Client request out dot slash client. Huh. G++. Client request dot cpp out client. Okay, client is working, and let's say we make another connection with the server, and again the same thing. Okay, and the server is not even closing the connection with the client, which is bad. What is the current status? Current status is error, and this is the error. And yes, we have written the event loop, so which is nice, which we wrote like day before yesterday, and today we wrote the application side code where we are making non-blocking IO operations on the application side. But the problem is this is not working. So there is some error with this. The client is able to read the first response by the server, but not the second and the third. And the server is not even closing the connection because it will say connection closed when connection is closed. So when we ran this client server here, that connection, this connection, and this connection are still there. So yeah, there are like 3 connections with the server right now. I think the client side code is okay. It is reading and it is writing. Let's printf len or yeah, new line given the length, we will see the length. Yeah, g plus client request dot slash out client, run the client. Okay, first the length was 18, then 0 0 0 0 0 0. Okay, 0, 0. So it was working for the first time, but then it stopped working somehow. Is our server not behaving correct? Well, it is not behaving correctly, but why specifically? Why don't you try to connect it with telnet first for testing? Yes, but I we cannot do that telnet because we have a protocol. In telnet, I cannot send my string like this. First thing has to be the size, and size in binary representation. I cannot say send in 12 and then write a string of size 12 because this 12 is not treated as 1 2. This is treated as 1 2. So whatever the ASCII code for 1 is and whatever the ASCII code for 2 is, that is the thing which is sent. But we do not want that. Yeah, so we cannot use telnet here. And you can see things per step might help or at least will reduce the time. No, we cannot use telnet here. That is what I was trying to use yesterday, but nope, we cannot use that. Because the string has to be formatted, which we are sending forward, and we cannot do that with telnet. Wait, uh, let's say here telnet google.com and port 80, right? We are connected to Google on their HTTP port, and if I send get HTTP 1.1 or something, then this thing that I have typed in, this string will go there, right? This string over TCP connection will go there. And if I press enter a couple of times, this is the response given to me by Google, and then the connection was closed by the foreign host by Google. And I can only send a string. The main point is I can only send a string like this, which I typed in here. These things were sent as a string of characters. That is what telnet wants us to enter, and we can only pass on a string of characters. What we want to pass on, because we are using a protocol, our protocol, well, actually, this protocol which we are using is not text based. Before the payload, the actual message, we have the size of the payload, and this size is has to be in binaries, right? Binary. The main point is that this message which you want to send from the client side, this has to be formatted in some protocol which we have defined, and we cannot do that with telnet. Yep. Yo, okay. And see, I think netcap can do that. It has pretty polished, sophisticated and complex features. Okay, I guess this is sophisticated enough. No, this is not sophisticated. This is pretty simple, but still, I don't know if we can do that. This is fine. Our, yeah, thing has to be formatted. This is not working. String parse. We are able to read everything correctly from the client, but the client is unable to read because the length is 0, right? Yeah, we saw that the client is saying that the length is 0. Handle right. Ah, handle read and handle write. Okay, these functions are also working. Okay, what are the things that I can check? Here we can check the thing that we are outputting. We can see the length. Yep, accept handle read, process payload here. Whenever we write this thing, we can check this, we can print it out. Yeah, we can print it out. Yeah, we can print this out. So we'll do printf %0 to x. Yeah, for hexadecimal, we need to print like 4 hexadecimal characters. I think we can do 2. Yeah, this is fine. %0 to, or a loop for int I equals 0. We have to first of all type in the length, print the length in hexadecimal format, and then we will print out the string to see what we are trying to write onto the server. I less than n, I plus plus, and printf in hexadecimal format, 2 characters in hexadecimal format, and this is on write I. N is nothing. Yes, makes sense. That is 4. And then printf. Then we will printf a new line, and then the whole string, and then a new line. And the payload is, wait, we don't need a new line. We can just, we'll add a new line. And after this, and the payload, and it will begin from write dot data plus 4. Yeah, let's go with this. Clear g plus plus event loop, compile as server, run the server. Server is listening. Go to the project dot slash client. Client says hello, this thing, and then we said, yeah, send this to the client. Okay, that is nice. That is like nice. 1 2 1 2. This is in hexadecimal format, so this one means 16. So 16 plus 2, that is 18, which is the correct length of this whole string. And this is in little endian, so this 18 here makes sense. This is the least significant byte at the first position, so this is correct. This is correct. Okay, so that is what we are trying to write, but then we are unable to write it. Let's see how much we are writing. Written person d, yeah, whatever. And And let's also print the string which is left on the whole thing, right? Dot data. Print this string from the start. And also later on, the server is unable to read the third request which is sent by the client. Everything got messed up. You need to set up your tool chain like makefiles, GDB. Yes, we can do that, but right now the main thing is just learning about sockets and everything. And CMake, yeah, I don't want to get into CMake just yet because that is not the main focus. One step at a time, I would say. It just increase the complexity, more of handling one more project. Yeah, GF2 is not available on Mac. Shit, I don't know what GF2 would be. But also, yes, this is also nice thing. The project is not too big, so we can skip that part. But still, the thing is that I don't know how to use CMake, so I should use CMake, but not right now. Yeah. Hello from server. Yeah, let's compile and run. Event loop, server, run the server. Okay, server is listening. Client. We have to do. Why was this thing not printed? Because we are writing this thing before. Okay, I guess. Okay, write does not exist, but okay, okay. We were not printing this before because I guess we were able to write the whole thing in one go. So that is nice. Event loop, event loop outside. Compile server, run the server. Server is listening, run the client and written 40. Should that how were you able to write 40 bytes from these are 18 bytes and then we have this much which is 4 bytes, so total we should be writing 22 bytes, not this much. That is a lot. So data is and here we are also passing in just the size, so let's see what the size is. Length percent d, right dot size. We have to type cast g plus plus event loop output server stop, run the server, run the client, and the size is also 40. So okay, that is the problem. That is the problem. Why is the size equal to 40? Yes, why is the size equal to 40 when we are doing this here? No, on this line, yes, y is the size equal to 40. What is the size of the string that we are putting here? Size %d, new line, and this is res.size. Same. Type last into integer. Client says this and delete this. This we don't need anymore. Comment this out. Okay. Event loop, compile, run server. Yes. Stop, clear, not cleara, clear, run the server and run the client, and the size is still, y is the size 40 here. Size is equal to 40, even though it should not be equal to 40. Put length. Okay, we are putting length. Stir dot size. Shit. Okay. Shit. Makes sense. Makes so much sense because we are using insert here, and 4 plus 18. 18 plus 18 is 46 plus 4, 40. That makes sense why the size was 40. Shit. Okay. Yeah. Yep. Okay. This should not work. The problem was that we were using insert here and we were inserting in the middle, like when I was creating response, the vector which we are going to send back, I was the total size of this response was equal to 4, which is going 4 bytes to store the initial length, and then also the size of the payload. That was the size of res here. Now I changed it, but before it was str.size, right? The total size and the res as it is supposed to be like sent back. But then I think I should make it equal to that thing, and instead of insert, we should use some other function which will copy the contents of this thing onto this thing starting from here. Copy. There are a lot of functions. Strings, yes. In the C++ programming language, we can go to the source and look for the best function for our needs. What? No GF even after getting MacBook? I mean, MacBook does not have a lot of Linux things. Is your loop correctly responding to all the requests in the queue? 18. It should print string. What? Is your loop correctly responding to all the requests in the queue, or it just looks at the first one, replies, and moves on? It is correctly responding. We were not writing the response correctly. That was the only problem. What is the output on the running client twice without closing server? Because on the client side code, I have like sending 3 requests on the same connection, and then at the end, the client is supposed to say exit. Yeah, here we have first request, first hello, second hello, and then the client says exit, in which case we would just exit. And here we need a better function for copying strings from one place to another, which we can probably find here. equal, these are for comparisons, strings, there we go, and basic string, nope, these are all the constructors. Fundamental operators, we have operators front, back, copy, pop, push, swap, taking in IO and strings, numerical conversions, string to integer, and all that. STL like operations, forward for getting the iterators, and then assign, append, insert, append. Yes, append is the function that we need. No, I want a function which will copy. We don't need append, a function that will copy. Replace, replace would swap. No, we don't want replace, we just want copy. Because the string that we are wait here, yeah, this is a string and yeah, it will just go out of scope. We want to something like copy would be very nice. Basic string compare. Okay, shit, chapter ended. Let's just use append. No mapping function call. Yes, because makes sense. Huh. Restore, because this is not a string, this is a vector. Shit, yes. But vector is also a string. You can use it instead. From the end, inside this. And let's compile, and this should still work. Not still, this should work for the first time. Event loop, server, run the server. Yo, client wants to close the connection. Okay, everything is going amazingly, but server, shit, yes, makes sense. I was reading. Yeah, the client is trying to read after exiting the connection. That should not happen. But yeah, this is fine. This is fine. The event loop is working correctly. The event loop is working correctly, and everything is okay. Everything is amazing. I saw the same course on Code Crafters. Yo, let's go. Try one BRC tomorrow. It will be pretty interesting. What is 1 billion record challenge? Shit. Row challenge. What is it? A fun exploration of how quickly 1 billion rows from a text file can be aggregated with like 1 billion RC. Calculate the min max and average of 1 billion measurements. 1 billion 10 power 9 C++, we can do that in C++. Okay, wait, Rust would be pretty cool. Time, language in Java, make sure to global leaderboards. Why is everything here in Java? The challenge, and the best one is 6 seconds. That is nice. Your mission should be to choose uh, your mission, should you choose to accept it, is to write a program that retrieves temperature measurement values from a text file and calculates the min, mean, and max temperature per weather station. There is just one caveat. The file is 1 billion rows. Okay, that is more than 10 GB of data. 10 GB. Shit. And the data is like this. Temperature here, temperature here, here. The program should print out min max values per station alphabetically. Shit, that is crazy. That is crazy. 1 billion row challenge. It was for Java initially, but people did it in different languages. The best time I could do is in 4.7 seconds. Yo, that is crazy. Hello, Prism. There are still a few optimizations I could do. It is very fun and educational. Okay, we can do this. We can do this in some stream. Yeah, but right now I want to finish this thing. It has already been, this is the sixth stream. So yes, I guess tomorrow maybe we can finish this. That would be nice. And yes, what is the current? And then we can do 1 billion row challenge, which would be fun. And wait, when I am much better in Rust, I would be able to do this in Rust. So that would be cool. 1 billion row challenge. Yep, that is cool. That is cool. And yep, what is the current status of this thing? The current status is that we have written event loop. That is nice. And yep, we have written event loop. And now we have written the application side also of the code. And everything is pretty cool, actually. Everything is pretty cool. Shit, maybe I can write code for the client side and make it interactive. That would be nice. Shit, that would actually be nice. Like writing a small version of Telnet. Yeah. Meme cache, memory cache question. The best engineering interview question I have ever gotten, part one. Google it. Okay. Get up the best engineering question, modifying part one. It is also on Hacker News. This guy, it has been more than a while. And what is this thing about? You know about memchats? No, well, it is in memory key value store. Okay, memcached. Okay, key value store. Here's the space. Let's download it. What is the question? It's been a good while since I received NDoc software engineering interview, but I still remember my favorite interview question. It was mem SQL circa 2013. Circa, yes, 2013. They haven't even kept their name, so I assume they are not still relying on this specific interview question. I don't feel bad for revealing it. It is a great story, so that I hope people, it is a great story that I tell people a lot. I have just never blogged it before. Okay, so this isn't a question per se, it is a programming challenge. I forgot how much time they gave for it. Let's say 3 hours, continuing counting the time to explain the problem. 24. I am reliably informed that it was 1 hour, not three, just the estimated below. Accordingly, since MemSQL was a database company, this is a database challenge. Okay, we have another challenge. Shit, what is the challenge? The challenge, is this the challenge? Or this whole thing is the challenge? Shit, okay, this is long. I guess I would not read this right now. A few things you should do beforehand before doing this is to learn about other hash map cause standard one is too slow, and learn about single instruction multiple dataset operations. Shit, we are going into assembly, I suppose. Adding new things in memory cache. Okay, this is the whole challenge, how to add new things in memory cache. The memcache people should give that type of question more. Did you try it? Yo, so this is nice. You can also do this at some point. Bookmark programming. Yep. And Okay, so we have written code for application side, but I haven't read the code. And yes, I haven't read this part. I just went on and wrote the code. So we will read this, but before reading this, I want to make this a bit interactive. So let's make this a bit interactive. We will write interactive client.cpp, and this thing would be able to read what we are typing and format the text correctly and send it to our server and get the response, display the server, and if we print exit, we would exit. Okay, cool. Yep, we need file descriptor equals socket for AF inet. We have to include some things. Include sys slash socket.h socket string and 0 now the structure to store the address stock adder addr initially empty include inet or net inet net slash n in dot h for adder dot fn family is af inet family and port host to network small port is 1234 and addr adder actual address is host to network long actual address is local address which is shit, loop back shit, localhost address in socket C++. There is a variable which we use for localhost like loop back or something. Client side, yes. Clear the structure, port this. I think no. Int adder and okay, in adder loop back. Loop back for localhost, and we will now connect. We will now connect this file descriptor and const pointer const struct adder or sock adder pointer address of this adder and size of adder const okay and if n that is connect would return 0 in case of success and -1 in case of error. So if this then error, and we can actually make this more general by changing in by taking even the port from the user. That would be nice, but let's not do that right now. Print error, we can add those things additionally later. Print error, unable to connect. Include stdio.h cool. And okay, so now the thing is connected. If not connected, then we will exit. Exit is also not included. Okay, now what do we want? We want to take in input from the user. So while true, We'll create in a string, yes, str and cnstr iostream and using std string std str. Okay. After taking in this thing, now if string equals exit small or small, then we will send this thing. Yeah. And if not equal to exit, then we will also ask for a response from the server, and we should write functions for these things. We will write handle. I think we can reuse the functions which we have written for the server here, interactive client. Yeah, we should be able to reuse functions which you have written there. 90 minutes. Damn, I'm gonna try to. Will do once I get free. Shit, I don't like data structure questions. Data structures are like crazy. Working like manually with data structures, it seems very manual labor type of thing. Yeah, it's like, yeah, I can, I would rather write assembly than writing a parser from hand because it feels like manual labor somehow. But knowing how it works is a different thing, but writing on your own, that is a different thing. Get length, this is a function we will need. Parser, parse is a function. We can, we don't even have to do this. We can use our code for client request here. This thing, talk. Max of, let's say, const int or define max buff as 404096. Makes sense. And then right length, right all, right length. These are functions in, I guess, format.cpp. Yep, format.cpp. Format this format.cpp. Cool. And yep, okay, these are working. Now we can split this into writing and reading as different things. Void write, write to, yeah, write to, takes in a file descriptor, int file descriptor, and the message char pointer msg message, and returns -1. We don't want that. We don't want to return anything. We'll just write, and we can rename this to read from. What is n? Makes sense, and there is nothing. Okay, makes sense. That is pretty nice. Okay, so whatever the person interacting with the program says, we will write it. write to our server. So first has to be the file descriptor and then str.data. Yeah, that is working. And if the string is not equal to exit, then we will also read. The first thing is the file descriptor, and the second thing is, wait, there also has to be a second thing. No, cool. Else, if the thing was exit, then we will say connection lost, and we can use cout. Cool. Okay, this should work. On the left side, the server is still running, and here we can compile interactive client. Memcopy and Sterling are not there. Memcopy and Sterling are not there. What is the normal client? Client.request. It is importing C string stdio. Yeah, let's just import these things and interactive client with C string is the only thing which we were not importing. Yeah, cool. Interactive client. Permission denied. What is it even trying to do? So, huh, shit. This cannot read my client. This program is only trying to read from the standard input, but it is unable to read because permission denied. Huh? Shit. That is bad. That is like shit, really bad. More closer to what you do in a job. Huh. Okay. So then it would be more interesting. That is nice. And shit, I changed my shell. Yeah, I was trying to do some things with my shell and shit, this is messing up. The program does not have sufficient permissions to read input from standard input. Interactive client, and it is not doing anything crazy, just normal stuff. I do have IO stream. Shit. Shit, okay. Yes, because I'm stupid. I was trying to run the source file. Okay, it is waiting. Hello there, server. Uh, shit, okay, shit. Since we are reading using, y- shit, since we are reading using the cin function, this was supposed, then this was treated as this is my first input, this is my second input, and this is my third input. Okay, and shit, okay, that is kind of crazy. And yeah, so hello, we saw hello, then there, then server, and now if we press exit, yeah, connection closed, and yeah, cool. We would like to change a few things here. I do see a few bugs. First of all, we don't want to print the length anymore. And after this, we will break out of this loop. And also, instead of this, we should use get line to read a whole line. Line on C++ from a standard input. Get line input stream, some string delimiter. Some string, why would we want to add in some string? Okay, makes sense. Get line std cn, this is a stream, and get it into there. And before this, we will say cout, enter your message. Cool. Standard cout. And also we have to change something on the client, on the server side, which is when we are closing the connection. Client wants to close the connection, we have to get an underline. Yeah, cool. G++, interactive client, out, client. And we also have to compile the new server. Event loop, output server dot match server. Server is different. Client. Okay, enter your message. Hello there, server. Client says hello there, server, and the server says hello from server. Let's say I am here. Can you see the messages? Okay, everything is working. And let's say exit. Connection was closed and connection closed. Okay, yeah, interaction is also going amazingly. Wait, it is not hurting my eyes to see. Wait, what is it? It is not yeah, hurting my eyes because I'm not writing the code correctly, or maybe the format. Yeah, that is nice. That is nice. This is working. The only thing left is to actually read what is the correct way for doing all of these things. Not the correct, but the way that they are doing this. Non-blocking accept. Yes, first we have to make accept a non-blocking request, and also all the file descriptors which we are creating, they also have to be non-blocking so that our main thread doesn't stop. Okay. 3 hours 23 minutes. Okay. Before entering the event loop, make the listening socket non-blocking with file control function. On this file descriptor, what we want to do is we want to set a flag. And what should be the new flag? The new flag should be this thing: non-blocking, or take bitwise or of non-blocking with the current flag. Then the event loop calls back the application code to do accept. And this is the handle accept function. Here we are creating a new data structure for the client and we are accepting a call. And if there was some error, then we will return null. Otherwise, we make this new file descriptor a non-blocking file descriptor, and then we create a new data structure. A new struct to store this connection, and we are saying we want to read on this socket later. Yeah, the connection socket is also made non-blocking, waiting for its first read. The connection socket is also made non-blocking. Yeah, okay. When protocol parser with non-blocking read, see the comments for each sub setup. Okay, first we have to do a non-blocking read. Okay, we read whatever we can into our buffer, small buffer. Wait, their buffer is bigger than the buffer that I'm using. My buffer is 4096, but their buffer is bigger. And if we were unable to read, then want to close and return. Okay, want to close and return if we were unable to read. Event loop, not this. Application, yep, application, yes, right here. This is on the read side. Wait, our read side code is pretty small. First, yes, we are also reading, and if we got some error, we are just saying we were unable to read, and then we are returning. I guess, okay, let's also say that we want close equals true. We will close this connection. Okay. If we got some error in reading, well, if that is the case, then we will do the same thing when we want to write, and we will say on this connection want close equals true, so that our event loop will close this connection whenever it goes through this connection, right? So we read and okay, and then we append the new data which we have read onto our buffer in which we have all the data which we have read till now. Then we try to parse the accumulated buffer, and if we can parse, then we will process the whole message and then remove the message from this thing and try one request connection. They are saying after reading append, yes, we are appending, and then try to parse, and if we can parse, then process, yes. And process also includes, yeah, deleting the whole thing and setting up for writing. So that is nice. We are handling everything correctly. The handling is split into try one request. If there is not enough data, it will do nothing until a future loop iteration with more data. Yes, yes, yes. Yes, if we do not have, if we haven't read enough, if we want to read more, then we will read more later and we won't process anything because we don't have enough data to be parsed and to be read or anything. Then process one request if there is not data. If there is not enough data, then we try to parse the accumulated buffer. Yep. And if the size is smaller than 4, then we cannot do anything. Then we will return false. And let's say if we were able to, like, if the length is there, then we first get the length. And we will see if the length is greater than what is required, then also return false. Yes, if we don't have all the whole payload, then we will return false. And then if we do have the whole payload, then yes, we get the whole string. Then we will parse the message and then generate a response. And where are we saying that we want to read? Buff append outgoing. Yes, write the outgoing buffer, write the request that we want to do. Buff append is their own function. Yes, and buff consume is their own function. Yeah, they have their own method of doing the same thing that we are doing. So yeah, nothing that we have to do too pedantic about. And then we use vector as the buffer type, which is just a dynamic array. Yes. And non-blocking, right? How are they handling the right? Assert that the size that we want to write is greater than 0, and it will be, because yeah, we are changing when the size is 0, we are Yeah, when the size is 0, we will not be calling the write handle write function. So yeah, then write, and if you were unable to write, then we want to close the connection. Okay, and then remove written data from outgoing. Yes, buff consume. Okay, state transition between request and response. In a request response protocol, the program is either reading a request or writing a response. At the end of handle read and handle write, we need to switch between the two states. Yes, we are doing this. Handle read, we are seeing when we are reading, update the readiness intention. If connection.outgoing size is something, then we don't want to read, we want to write. And if the size outgoing size is 0, we have written everything that we wanted to write, then we will say want to read is true. We want to read now because we have written everything, and we do not want to write anymore because we have nothing to write. Okay, this is not universally true. For example, some proxies and messaging protocols are not request response and can read and write simultaneously. Okay, that is crazy. That is all. The protocol is the same as in chapter 4, so you can reuse the test client. The server is the bare minimum that resembles something production grade, but it is still a toy. Go to the next chapter for more advanced stuff. Okay, there is going to be more advanced stuff in the next chapter. Right here, event loop part 2. Event loop part 2, that is going to be crazy. Now, event loop basics. Okay, we have written our own event loop. So what is going to be here? Whatever it is here, we will do it tomorrow. Buffer begin data. Okay, we will have a new protocol, it seems like. Okay, and in the contents, then we will have the database related thing, key value server, request response message format, this thing, nster handle request, parse, process the command. Shit, this would be the actual Redis kind of thing. We have something working, but making stuff work is not the hard part of programming. Here comes the advanced topics: coding low-level data structures beyond toy code, applying data structures to the real-world problems such as timers and sorted sets. Okay, shit. I don't think we will be doing that. Yeah, I won't be doing implementing hash tables and all of these things. Implementing hash tables, balanced binary tree, sorted set, data serialization is something that I would like to read, but I don't want to implement data structures in small language in C. We can read about thread pool, but yeah, for now, this would be enough. This would be it. There are 2 chapters remaining, event loop part 2 and key value server. And it is going to be fun. It is going to be fun. Yes. And yeah, this is the state of the code right now. Code base. Yes. A lot of code here. Git status, we have modified some things and added new files. And let's say event loop, message, updated event loop code. Shit. Git commit message updated event loop. Okay, and now client request, we have modified client request. What have we modified in client request? We have added a few lines which we removed later. We should not have any printf here. Should we still have printf here? That is bad. Yep, assert is nice, and if exit, yeah, that is, yeah, we can change that. We added this and then this. Client request, there are still some differences in client request. Git diff. We removed one line, okay. Client request after this thing, there has to be a line here and get a status that is nice application dot cpp. Okay, yes, git add application, git added application, my code, yep, and git add shit, git add, okay, interactive client and struct git commit message and added a interactive client and helper master. That is nice. That is nice. CP stream till you build this project. Yes, this will be done in a few days, maybe 2 days, 2 to 3 days. And yes, I am not streaming CP, competitive programming. Yeah. And this is it for today. This is nice. We wrote our own event loop. And not just that, we wrote a interactive client, which is pretty nice, which takes in the string which we pass in into the CLI and yeah, in the CLI and formats the string, sends it to the server, takes the response and gives us back the response. That is nice. And yeah, we also wrote the application side code for the event loop. Yeah, yeah, today was nice. Today was nice. And yep, for today, that would be it. And thank you for being here. Bye.